Hi, everybody. Welcome aboard to our next awesome data and AI online meetup session, Encoding Multi-Layered Vega-Lite COVID-19 Geodata Visualizations. What's also super interesting here is it's basically managing the visualization lifecycle with the MLflow model registry. So it's not just about machine learning models, it's actually very much also about visualization models. Now, let's hold for a couple of minutes so that way we can just go ahead and let people log in. And meanwhile, if you have any questions or thoughts, chime them in right directly into the Q&A panel. We'd love to go ahead and actually answer your questions. And also in the interim, let us know where you're from. The reason for example, I have a virtual background in the back is because I'm from lovely smoky Seattle. So it's just a tad hazy with an AQI, wonderful AQI currently of, let's say, 269. So just a tad bad for the breathing public. Meanwhile, yes, like I said, in the chat, go ahead and let us know where you're from. We'd love to know. Cool. We got some people chiming in right now. We got some folks from London. That's awesome. Welcome aboard. Somebody from Italy. That's excellent. That's cool. So we are truly global. That's awesome. From smoky San Jose. Yes, unfortunately, the West Coast of the United States currently is a tad bit smoky. So apologies for that for everybody. Yes, everybody's currently, if you're wondering, everybody's actually muted. This particular session, we actually will not have anybody speaking outside, of course, the two speakers themselves, or sorry, three speakers, including myself. But you can ask questions by using the Q&A panel on the bottom of your screen. So at the bottom of your screen, there's a little Q&A button. So please ask your questions there, okay? All right, perfect. It's 9:02 Pacific, so let's start the show. I think we're going to have a fun one. So just as a friendly reminder, again, this is Encoding Multi-Layered Vega-Lite COVID-19 Geodata Visualizations. It's about managing the visualization lifecycle with MLflow Model Registry with Andrew Bauman and James Hibbard. My name is Denny Lee. I'm a developer advocate at Databricks. I've been working with Apache Spark since its 0.7 days. Worked at Microsoft prior to this and over at Databricks now. I'm a huge fan, of course, of Delta Lake and MLflow. So hence we thought this would be a great session where Andy and James will talk about how they're not only using MLflow as a machine model registry, which of course is expected, but they're also using it as a visualization registry as well, which is pretty cool. So without further ado, let me go ahead and allow Andy and Jim to go ahead and introduce themselves. I'll be in the background. I'm going to mute and close off my video, but I'll be answering questions in the Q&A panel. And if you're on YouTube Live right now, I'll be doing the same thing there as well. All right. So without further ado, Andy and Jim.
Thanks, Denny. So your panel, all of your panelists today are in smoky Seattle. So we'll do our best with not coughing, etc. My name is Andy Bauman, and I am a technical lead at Seattle Children's. I specifically work for a project called Rerun, and the goal of Rerun is to help deliver products to particular users in the ICU to help them with their research, to help them in decision support. And a big part of that is not just managing and having models. In fact, I would say probably the least amount of time is probably spent on making machine learning models and other types of models. And a lot of time is spent on how do we communicate the information that models and other pieces of information that are available. How can we communicate that to our users in a way that reduces their cognitive load? And typically that's a visualization. And a visualization is also something that's not prescriptive. So visualization is something that can help someone make a decision, but it's not telling them what decision to make necessarily, right? So then that's what we want. We don't want to be prescriptive. In particular, we don't want to tell people who are domain experts what they should be doing, right? We want to help them take in information and integrate that with their domain knowledge to make decisions. And visualization is typically the medium by which we do that. And so it's very important that we have a way to manage the visualization lifecycle, including deployment. And so in addition to going over the GeoViz today, we'll also be covering elements of managing that visualization lifecycle. And I'll turn it over to Jim for a second to introduce himself.
Hi, I'm James Hibbard. I'm a data engineer at Seattle Children's in the Research Scientific Computing Group. So I work a lot with researchers and physicians who participate in research on projects around genomics and image analysis, and sometimes on hospital operations projects. Like Andy said, a big part about communicating results, whether they be from a model or from raw data collection, is through visualization, either a static figure or as part of a larger dashboard. This isn't just important for communicating details within a specific domain, but it's a great tool for communicating across domain experts. You might have a statistician who speaks in kind of one language and a researcher who specializes in genomics or in image data, and being able to look at a graph or a picture can help bridge communication gaps in jargon or specific lingo. So I'll pass it back to Andy.
So I'm going to share my screen. So we worked up a demo of this in Binder. We had a little bit of difficulty launching it this morning for whatever reason. So I do have a local version running as well if we have to switch back to that. But I'm going to try to do this out of a repo that has a build with Binder. If you're not familiar with that, it basically Dockerizes what we're doing and launches it via Jupyter Hub. So that's something that we could probably provide to participants, maybe 48 hours out of this if you're interested in having the code. So I'm going to share my screen. All right. Jim, can you see it? See the screen?
Yeah, it looks great from a perspective.
Yeah, okay, great. Screen looks great.
Okay, great. All right, so let's get into this. All right, so let's start out with what is a model. And I think my favorite commentary of all time about any sort of model was by George Box, who is a very prolific British statistician, who is attributed to saying all models are wrong, but some are useful. So definitions of models in rigor vary within and between disciplines. The general consensus is that a model is a representation of a thing, such as objects, processes, phenomena. So for example, you could have a scale model of a building, or you could have a machine learning model. A simple model may be one that represents a system by taking in data and returning descriptive statistics. So maybe you'll take in a bunch of data, and maybe your model is always returning the mode, or always returning the mean or the median or something. And maybe that tells you something about the system that you're working with. That would be an extremely simple and probably not very useful model, but a model nonetheless. And a more sophisticated model may take in large amounts of data and pass it through, say, for example, multi-layered networks. So a deep learning model or something to that effect. So what are some examples of models? We have statistical models that include Bayesian models, regression models. There's medical models, which is something that we work with quite a bit. So there's pediatric sequential organ failure. That's PSOFA. PARDS, it's pediatric acute respiratory distress syndrome. The adult version is just ARDS and SOFA. And then there's NEDOCS. NEDOCS is something that we work with quite a bit at Children's, and actually do have a machine learning model that helps us with that. And that's a model that's used to predict surge capacity in emergency departments to inform staffing and other elements that you need to deal with a surge. And then there's modern major generals. And if you get that joke, I really appreciate it. All right, so what about visual models? So as I mentioned before, a visual model could actually be a scale model of a building. It's just something that helps you understand a system of information in a way that you can easily digest it, and basically, and not make your head explode. So visual models are common, but visualizations are seldom treated as models. And visual models can transmit a lot of information while reducing cognitive load, as I mentioned before. This is the whole point of doing them. And we can actually encode visual models, register those encoded specifications, and manage them just like statistical and machine learning and deep learning models. And that's what I'm going to go over today. All right, so this is a local setup. We don't need to go over that right now. All right. So the first thing I wanted to do was launch my MLflow server, which I did. So I have some commands here. You can see right here that launched the server, and the server is launched. And if I travel over to the URL, let's make sure this is still actually serving. It is. And so you can see the MLflow UI here, and we're going to make use of this shortly. I should mention here that what we're doing is actually intended for, up to production level front-end deployments. And we have done front-end deployments with this. It's not actually meant for visualizing in a Jupyter notebook, although we can. So I have some helper functions that help us do this, but typically what you would be doing is delivering a visualization specification to, something that would be displayed in a browser on a web page, so or a dashboard or something like that that you would be delivering to your user, or some other similar UI, not typically a Jupyter notebook. So functions that help us visualize this. And before we go too far, if you're not familiar with VegaLite, I'm just going to read exactly what VegaLite is from their website, because it's better than I could ever make up.
Oh,
so
hey,
VegaLite is, yeah.
Oh, sorry to interrupt. Just as you go, can you zoom in just a little bit? Some of the readers are having a hard time seeing it. Just as.
Yeah, sure.
Perfect.
How is that?
That's perfect. That's perfect. Thank you very much.
Yeah, no problem. Thanks. I'm glad you told me. All right. VegaLite is a high-level grammar of interactive graphics. It provides a concise declarative JSON syntax to create an expressive range of visualizations for data analysis and presentation. VegaLite specifications describe visualizations as encoding mappings from data to properties and graphical marks, such as points or bars. So what this is saying is basically it uses the grammar of graphics, which I think most of us are probably familiar with, especially if you've encountered ggplot at all. And it actually encodes the visualizations as JSON specs, and that's why they're so easily deployable, because they're deployable in modern web browsers. So it's actually a great way to go from a visualization you want straight to a deployment into a front end. And so I've got an iframe here of an example visualization. So a lot of times when I'm developing a visualization, I want to start off with something that someone else has done. And in this case, maybe I want to develop a visualization for displaying PSOFA, pediatric sequential organ failure. So PSOFA is made up of scores of 6 organ systems, such as cardio, neuro, renal, hepatic, coagulation, and respiratory. And each organ system, every 24 hours, is given a score. There's some data that goes into giving it that score, and it gets a score of 0 to 4. The more normal the system is, the closer it is to 0. The more outside of normal physiological ranges it is, the closer it is to 4. Those 6 scores get summed up into a score 0 to 24. And that 0 to 24 score can be used for a number of things. But one of the things it's used for is to really tell which patients are doing well under that system and which patients they're not. So my understanding, and I'm not a domain expert, my understanding is that's one of the things that goes into maybe assessing whether someone is in danger of sepsis or other sorts of complications. All right, so for that I might want a line plot, and maybe I want a tooltip. You know, some interesting interactive element. And so I went onto the VegaLite site, and I found this. Visualization. And then here's the JSON specification that goes along with it. So if we copy and paste that specification. So first, actually, I'm going to call in my style that I use for managing these visualizations. We can share this code later. And then I've taken this visualization, or I've taken this information here, and I've pasted it as a raw string into the browser or into my cell. Execute that. Now, notice something. I removed the data. I removed the data from this. And that's because when you register a visualization, you don't really want to register it with data already inside of it. That would be like registering a machine learning model that already had just one data set that it could run. And then no matter what anyone wants to run across it, it will always run the one data set that you've hard coded into the model. That wouldn't make any sense. So one of the things I do is I remove the data set and just leave it as blank. And then we have some helper functions that we use to repopulate the data. So I've found a place where the data is. So this is a CSV in a publicly available repo. And then I'm going to use the helper function to put the data in there. And you can see the schema has been put back out, and you can see the data here has been populated. Now, I am actually using the predict function from the MLflow PyFunc flavor, because that predict function has to be implemented if you want to use the, not the PyFunc, yeah, I'm sorry, it is the PyFunc flavor. If you're making a new version of that, you have to implement predict. So I co-opted predict to put that data element in there. But we will probably rename that and refactor that a little bit later before we release the code. All right, so now I've rendered the visualization. Let's see if our tooltip still works. Great, all right, so I have that working. Now I want to reuse this visualization specification. I'm gonna do it in a manual way and transform it into something that would be useful for PSOFA. So as I said, PSOFA is comprised of subscores 0 to 4 from 6 organ systems. It's assessed in 24-hour intervals where each patient receives a score of 0 to 24. 0 represents the more normal end of the neurophysiological spectrum, and I misspelled physiological. And then obviously, as you get further from that, you get further from the normal physiological neurological range. So the way there's a number of ways that you can edit these visualizations, but I am going to use the Vega editor. And then what you can do, I'm not going to walk through the whole thing, but what you can do is you can just, do find replaces. So I could do, I could replace price, for example, with score. All right, so now you see when I do this, my visualization starts to not make any sense, right? It's showing the outlines of visualization, but it's not showing anything. It's because I'm pointed at the wrong data. All right, so the data that I have, instead of having price, it has score. Instead of having symbol, it has identifier. And then instead of having these fields down here, it would have patient identifiers. Now, I just want to say the data that I'm using and the patient identifiers are completely random and made up. This is not real data. It's got the right numbers in it, but it's not in any way, shape, or form real data. It's completely fake and completely randomly generated. All right, so I'll just show you what happens when we do all these replacements. Okay, so if you go here, you can see that I've replaced symbol with identifier and field with score. And then I've replaced these other fields with some random patient identifiers, or these are fake patient identifiers. The data is random and the identifiers are just fake. 1, 2, 3, 4, 5, 2, 4, 6, 8, etc. They're not even the right number of numbers for an MRN. All right, so I'm gonna put this in here. And then I've also have some data here that I put up in a GitHub repo. And I'm going to put that data into the spec like we did before using the same predict helper function. And then it renders. And this is the same base visualization. I've got my tooltip and I've just switched it over to be something that's more useful to me. All right, so that's kind of the manual process. So what now? All right, well, maybe I want to start managing this. Now that I have something to start with, at least that I like, I want to start managing it. I might want to point it at other data at some point. Maybe, a new file gets written somewhere each day and I want to read that. Maybe I'm reading it from a database, whatever it is. So I can change my data pointers. I can change my encodings. I can start to work with the users and see what they want. But to do that, I kind of have to get it up in a management system. All right, so what I'm going to do is I have a helper function that helps me write a specification to a file. And that's what I'm going to do. And I'm going to have to zoom out here for a second and show you what I've done now is I have some helper functions and it's written some files. And if I actually go look at this, you can see again, this is my spec again. There's no data in it, no data pointer. And these are the specifications that I'm writing. 2 files. All right, and now I'm actually going to hook up with the MLflow, and I'm going to register a model. And you can see it says I've successfully registered a model. I'm not going to take its word for it. I'm actually going to go here and check. So let's see what's happened. Oh, I see now I have an example experiment here. If I go look, something has actually run. I do have version 1 of a model. All right, so next, let's see if I can go through and search that model. So I'm looking for target version 1 of PSOFA, and I want the stage to be production. Let's see what happens. Oh, I've got an error. The reason I have an error is because my search criteria haven't worked out, because I haven't actually pushed this to any particular stage. So I'm actually going to transition that into the correct stage. Now, I'm going to try to load this back again. Actually, I have to run the search again. Oh, and now I have a specification because it actually found it, because I had actually pointed to production. So this is one of the elements that you can use to manage it. So if you wanted to switch a visualization out, you can make a new visualization and then you could change this tag in the background to staging or production, or you can customize your tags. You could have a custom tag. And your search criteria just have to work that out. We're doing kind of like a lower level manual or a lower level search here. We have some actual search functionality that's built on top of that, which we can also share at some point. That makes that work a little bit easier. All right, so then again, I used a predict function with my data pointer omatic 6000 and pointed it back at some data. And again, we had the visualization. So the difference here is that I didn't just hard code a spec into here. I actually registered a spec as you saw up in the registry. I pointed at a stage, I searched that stage and version of the model out, and then I pulled that spec back down, populated the data pointer, and then rendered it. So this is something that I could have up in a registry. Someone else could hit that and pull it back down. into production, into a front end, and to whatever it is you want. All right, so now let's go over the Geo Visualization. All right, so I should say what we're going to do with the Geo Visualization is it's going to be a visualization of the United States, and it's got the definitive healthcare hospital beds, as well as the New York Times COVID county level data. Both of those data pointers are pointed at the live versions of the data. So it's the most recent hospital beds and it's the most recent COVID count. So those are on public repos, and you can hit them, and that's what they're pointed at. Previous to this, we worked out a visualization where we had done some encodings and basically made it so that we looked at the number of ICU beds available, and then the number of ICU beds and the number of ICU beds available. And we made it such that the more the encoding such that the more ICU beds that you have and the more that are available, the bigger and the darker the circles will get. And then the less ICU beds have and less available you have, the smaller and lighter the circles will get. That way, things that aren't as relevant to you will disappear into the background, and things that are more relevant will go up to the top. And then we added a tooltip that can give some more information. Now, this is not something we're actually using. This is something we did for illustrative purposes, but it's something that someone actually could use. And it's really illustrative of how all this works. So what we're going to do today is we're actually going to start out with, where we had all the encodings and everything all worked out, which was itself a process that was managed through MLflow. And we're just going to work with being able to select a certain geographical region, basically being able to select by state. All right, so first let me explain the spec. So here's the spec. The top level element is the hospital beds data. And then there's a transformation that takes place. There's a lookup transformation, and it looks up the COVID information by county using the New York Times data set, their live data set. It does a lookup operation and aligns by the county FIPS. And then it does another lookup using a Geojson object, which is commonly used in D3 visualizations. And then what that does is that creates a data flow, which produces the final set of data that we'll actually be visualizing on. So after that, we're going to have a layer element, and the layer element does a geographical projection, this top one. It does another geographical projection, and then it also does some encoding surrounding bed utilization, as I discussed before. So that's what this, it took a lot of iterations to actually get this compact, and that was all had to be managed by MLflow for us to be able to track what was going on. Otherwise, we would have been lost, and it would have been difficult to pull up old versions. So this is what it looks like when it renders. So you've got your tooltip. I don't know how much the tooltip you can see zoomed out, so I'm gonna zoom out a little bit. Just point at something maybe like down here so you can see it a little bit better. All right, so you've got a bunch of information here. So basically this would be like, oh, I'm interested in this big red splotch over here because this is relevant to me. I want to find more information out about that. So you can find out, number of ICU beds, adult ICU beds, other information like that. Right, but what if it's not relevant to see the entire United States at once? I should also say for cases, this is the total cases that are total cases that have been counted. If you really wanted to make this super useful, you'd have to take some sort of a diff where it's like current active cases. So like I said, this is just for illustrative purposes. It's not too much of a leap to go from this to that. So now what I've done is I call this the Washington spec. So I just want to see the state of Washington. That's where I live. And so what I've done here is in order to see the state of Washington, I've just done a filter. So I've called a filter in 2 spots in both projection layers, or in the projection layer and then the encoding layer. And I just say filter by the state of Washington. That's all I do. And then then we register that, and here we have the state of Washington. Now, sometimes you see these splotches of white. That's actually missing data for one reason or another. There's ways to handle that, but for right now, I just wanted to keep the data missing to let people know, hey, the data is missing here. This warrants investigation. Let's find out why the data is missing, and then find out how to handle it rather than just try to cover up the missing data, which would not be a good thing to do. All right, so now what if I wanted to select by state? So if I wanted to select by state, I would replace those filters with a selector. So this is something that you can use in Vega and VegaLite. And now I've said, I've set up a selection. I've just said filter by a selection. The selection is state. And I've added that again in the same two places I had the original filter. And now I've rendered this visualization. Now it's default to the state of Washington, but you know, I would, since someone's in Smoky San Jose, I would do California, but California is currently missing from this data for whatever reason. So since we got the data from the COVID data from New York, let's take a look at New York. All right, there's New York. We can get New Jersey. And also spell it correctly. That would be helpful. There we go. And so on and so forth. So I think you get the idea here. All right, so this is a lot. If you were just, you know, pushing this up to repos, you know, you could try to manage it that way. It wouldn't be very handy for deployment. This is a lot to do. And I thought I'd also mention here, you notice that I'm using named data sets. That's a strategy I use for the data flow. And so we can actually also pass an entire, we don't just have the ability to pass in a string. This is JSON, so you can parse it any way you want. So our helper functions can also pass in the entire object of the named data set. And that's what I'm going to do. I'm going to pass data into this. Get that spec. And then, sorry, the chat thing was in the way there, I had to move it. All right, so then what I'm going to do is I've just sort of, I've used some dictionaries and list comprehensions to help me register the visualizations. I won't go into the details of that. But I've just sort of automated the registering through visualization. And so I'm calling these, you know, the model name Geo examples. And then this is some code to create the specifications as files and then register them. So I'm going to execute it. And we get a message back from MLflow that says, in fact, things have been registered. And let's see if that's actually happened. We'll refresh our models. Oh, there we go. There's our geo example models. And if you go look here, we got 3 versions of our models. All right, so now let's go and search these out. So we're gonna search for 3 statuses. We're gonna search for I'm iterating over versions down here, and I've got 3 statuses set up here. And so what I'm going to say is find version 1 registered as none, version 2 registered as staging, and version 3 registered as production. All right, so let's see what happens when we do that. And then I've got a little list comprehension down here that should render everything. And lo and behold, I only have 1 visualization. So why is that? Again, it's because we actually have to go in here and we'll say, make this staging. Okay. And then we'll go to version 3. We'll make that production. And by the way, you can programmatically change the stages. I'm just doing this because it's the best way to illustrate it, but this can all be programmatic through an API. Right? So you don't have to manually do this, although it is helpful to be able to manually do that through the UI. Now we should register all 3. Oh, but we don't because I forgot to rerun the search. So I should rerun the search. Now we should have pulled down all 3 specifications. There we go. All 3 versions of our model have been pulled down. All right. That's all I have for that part of the presentation. Jim, did you want to take over and show your piece, or do we want to answer questions, or what do you think, Danny?
Oh, sorry. Yeah, actually, I think probably the best thing for do is for us to go ahead and continue the session. So Jim, you start. Andy, why don't you go click on the Q&A session? There's some questions that have been popping up. So why don't you answer those in the interim?
All right, sounds great.
Perfect. Jim, go for it.
Okay, I was feeling so relaxed here. I just I could hang back and not worry about anything. Andy did a great job showing different ways that we have created visual models. And I think that it shows a really important aspect of why this is a good thing to track. So in the case of the scoring models like PSOFA that were mentioned at the beginning, where you might plot a physiological like risk score based off of a patient, you know, a patient's baseline is going to be very individual. So if you have a ML model or a statistical model that considers that patient's history, you might be able to fit, you know, horizontal or vertical lines like a control chart that are specific to that patient, update that specific plot of their risk score as a decision support tool. So there's a lot of applications for being able to customize these models programmatically and then track who got a certain iteration of that visualization can be very handy. So for my part of the presentation, I'm going to go over some basic ideas of how the visualization flavor came together as a package and how it can be customized to be used with other visualization and plotting tools. So we saw a lot of instances of using VegaLite specs as sort of a dimensionality reduction algorithm, taking data or summary data and transforming it into a visual representation of that data to, you know, convey information efficiently. But as I think Pooja Singh, you know, kind of hinted at with his question, you know, there's a lot of libraries out there that are great for doing this sort of visualization work. You know, why pick just one? Why focus on Vega or Vega and VegaLite specs? And the answer is there's not a great reason to focus on just one. We prefer that for our work, but there's other use cases where a different visualization tool would be preferred. So we really built the visualization flavor for MLflow with that in mind. We designed it so that people would be able to bring along their own visualization library and still be able to track and use those visualizations as a model. So just really quick, I'm going to start up my MLflow server and then register a dummy visualization. And here I have kind of a silly visualization about barley yields for different varieties. It's not really important what the data is here. It's more important that we have a model to kind of discuss how this came together. So a key component of the API for the visualization models is that they're displayable. So a given model is able to take the raw artifacts that are registered as part of a MLflow run. Those artifacts are stored by the tracking server, in this case as a config and specs. But depending upon your visualization library, it could be PNG files or a blob of JavaScript wrapped in like an iframe tag. It could be a lot of things. But the displayable part of the API is basically requiring a specific visualization library to say, hey, for my artifacts I've registered, here's how I pull those out of the MLflow tracking server and display them, displayable, within some runtime context. So since all these different libraries and runtime contexts, whether they are a Jupyter notebook or a Rack.js dashboard or some other tool, because those have different requirements, we took a dependency injection type pattern to the flavor. So while our Viz flavor is sort of our interface between MLflow and visualization models and is API for how different libraries can declare themselves displayable and provide a method for that display feature, each library is able to provide a style as part of that Viz flavor. So where a flavor within MLflow is a way to, as a compatibility layer for different model libraries, a style is a compatibility layer within the Viz flavor in general. So the way that that's implemented is with Python namespace packages. So if you're not familiar with namespace packages, they're pretty simple. They're a way for two or more Python packages to be merged into one package through installation. And to hint to the Python compiler that two packages should be merged, you're required to have a package that doesn't have a init.py within it. So in this case, in our model Viz flavor package, we have this styles directory without an init. And the way that we implemented our Vega style is we had a separate package that implemented the same file structure, but had a Vega.py. And that Vega.py provided functions for displaying itself and for declaring its dependencies. So what we're able to do at runtime when you're creating a style is we can iterate through all the packages that are under that style directory and collect them all, mapping the package name to the actual module itself. And here's a little code snippet to demonstrate how that could be done. And I've pulled out from the visualization flavor itself these two functions here, the iter namespace and this discover styles dictionary, to show how that would actually look in practice. So this function would iterate across all those different styles. And this dictionary comprehension is collecting all styles that are present. So here we see that there are two styles present. There's an Andy style, and then there's a VegaLite style. So the way that we would use a different style is within our visualization flavor, we're able to accept a string, and that is the name of the style we want to use, and index into all those discovered styles. So if someone had a novel visualization package or a new approach to mapping data to a visual, they would be able to make a package that has this structure, and the model Viz flavor would automatically discover that style and provide it to any model that you want to track with MLflow. And so the Barley Viz model that we tracked at the top of the notebook, I'm going to load it, but I'm going to load it with two different styles. So each style has a different understanding of what it means to be displayable. And let's take a look. So if I run my first model with the VegaLite initial, I get back the spec. So this isn't a great display, but it counts as something that we could display that represents the visual data. It's a description of the visual data, so it's maybe not the most useful version for us. And here I'm going to use a different style that actually has a method that makes it displayable as an image. So this is nice for a few reasons. If two visualization styles have the same requirements to display something, you're able to actually mix and match across two visualization libraries. So in the case of Vega, there's Vega and VegaLite, and they both have similar configuration. So you might fit a visual model in one style and then use configuration information from that style, but display it in another visualization library using things like linear versus log scale, the domain and range of an axis to kind of denote what an important range is. There are multiple possibilities there. You can also target runtimes that are outside of the notebook that are more production ready. So here I'm going to use a style, but I'm going to target a runtime that is more like a dashboard, like a static website. And so this is nice because we could stack our visual models just like you might stack an ML or statistical collection models to make a full dashboard. And now I have the full history of my visualization, all the way back from, like maybe my data ETL into some statistical summary, and then how that statistical summary and site information was used to make a part of a dashboard or a full dashboard. And now I have a great audit trail, especially if I'm customizing these visuals, per patient or per user. I can say, oh, this person got this specific visual that was produced through this specific pipeline with this data at this time. So if auditability is important within your application, this can be quite nice. Normally, visuals are not tracked to that fine grain, which is a shame because they're one of the more common ways this type of information is consumed. So I'm just going to flip over to my MLflow tracking server really quick and show how this information is laid out within our artifacts. So if I look at my ML model file, I can see that the flavor that we're using is this MLflow Vega or our Viz model flavor. But if I switch over to my conda YAML, which collects all the dependencies for this model, I can see that we actually have those styles both registered. So because the packages for different styles for different visualization libraries are merged just by installing packages with the same structure, when you go to register them, all their dependencies for each of those individual styles that are part of your flavor are automatically bundled and saved for you. So that really eases collecting all those dependencies. So I hope this was a helpful look at how you can treat visualizations as models and track them and iterate on those visualizations to make them progressively more useful to your users, to yourself, and for your application. And thank you for taking the time to come to the talk.
Perfect. Thanks very much, Jim and Andy, for this great session. This was extremely enjoyable. Andy, I think you had planned to answer one of the questions that was on that was from the Q&A. By all means, go for it, please.
Yeah, I think the question was was about the samples from the hospital beds. So if you want to find out more about that, how that data works, go to Definitive Healthcare site. So that's where that data comes from, and they have a pretty detailed layout of how they get the data and how the calculations are made. And
perfect. Oh, sorry, go ahead.
Oh, I was just gonna say, if when we send out the notebooks, there's a link. I have links to the data sets. So when we do send this notebook out, then you can follow that link to the data set and subsequently probably follow any other link to whatever information you would want to know about that hospital bed data set. It's also, the data set's also available. Yeah, I'll just leave it at that. You can probably just follow the link when we send it out.
Yeah, so just to let you know, by the way, the data set is actually available also in Databricks datasets. We actually pop it directly to the. So if you're using Databricks, then you're more than welcome to use that, of course. In addition to that, yeah, it's actually available publicly. So just literally type in definitive healthcare hospital bed, and you'll be able to see the information there. So cool. Well, I think that's really it for today's session. Looks like there's no other questions. So thank you very much for engaging. Be on the lookout for the link from YouTube, because we're going to go ahead. Sorry, it's actually currently streaming on YouTube live right now, but we're going to update this in the next 48 hours with links to the public repos that Andy and Jim were talking about. So that way you can go ahead and play with it yourself. Okay. I think that's it for today. I did want to call out also that we have another session coming up on this Thursday, actually. So I did want to go ahead and call that out real quick. And for this Thursday, there's actually a tech chat with Simon Whiteley and myself on discussing SQL Server and BI to Delta Lake and Lake Houses. It's going to be on this Thursday, September 17th, 9 a.m. Pacific, 1700 GMT, if you're out in the UK, because Simon's actually based in London. Both of us are actually former Microsofties in one form or another. That you was very much in the world of SQL Server and BI. And like I said, we did the transition to Delta Lake and Lake Houses. I figure there's going to be a lot of cool questions that people are going to ask about this stuff. So a little bit of shift from MLflow visualizations and MLflow visualizations that we discussed today, but nevertheless, that is what Thursday's session is going to be. So again, thank you very much for taking your time to join today's session. Jim, Andy, anything you'd like to add before we go?
I just wanted to thank everyone for joining. It was really fun to be able to present this to everyone. So thank you.
Yes, thank you.
Perfect. Again, well, thanks very much, everybody. We'll see you on Thursday. All right. Have a good one, all.
All right.